All right, guys. So we're going to add to our chapter 5 notes again about linear functions. So far we've talked about slope. Today and tomorrow we're going to talk about direct variation, which is kind of the most basic linear function that you can have. And we're going to do that on page 53 and 54. So we're going to take a look at that. So if we turn to page 53 and 54, this time I actually want to start on the left-hand side on 53, inside here. So on the inside here, we just have our most basic, like what is direct variation, and a few examples that we'll go through. So firstly, what is direct variation? Direct variation is an equation that starts at the origin, or 0, 0, and grows at a constant rate. That constant rate that we talk about, so our constant rate here, it's really just slope. So like we were talking about the past couple of days, there are lots of different ways we can find slope. Rise over run, we can do our slope formula. But the interesting thing here is if I think about that slope formula, so if you remember, m equals y minus y over x minus x, because I know that with direct variation, it will always start at 0, 0, I can almost plug in that for my x and y. So we'll have y minus 0 over x minus 0. So really just y over x. So it's like our slope function, or our slope equation is a little bit easier. It's really just y over x, and that's it. And because this is so unique or so special, because it goes to the origin, they don't use m to represent the slope in direct variation. They use k, which is so silly because they mean the same thing. K is just for constant of variation, and I don't know why they were trying to be cool and use a K instead of a C, but they did. So really your equation is just going to look like y equals K times x, where really K is just slope, or m, times x. So let's say, for example, I gave you the equation y equals 4x. That would be direct variation because the equations match. There is no addition or subtraction. It's just a number multiplied to x. So that's how I know that it's direct variation. Now, when I make my table, I always still like to pick negatives, positives, and 0. And because it's not a fraction, you can really pick whichever x values you want. So I'll just go with our old standby, -2, -1, 0, 1, and 2. And because y is represented by 4 times x, I'm really just going to plug in each of these x values. So -2 times 4 is -8. -1 times 4 is -4. 0 times 4 is 0. 1 times 4 is 4. And 2 times 4 is 8. So we can see that it is growing consistently. It's going up by 4, which makes sense because that's my slope. It's also going through the origin, 0, 0. And I can see that on my graph as well, because if I were to plot these points, so -2, -8, -1, -4, 0, 0, 1, 4, 1, 2, 3, and then 1, 2, 3. We can get our nice straight line, which I don't know where my ruler went. And I can see that my slope is like up 4 over 1, so 4. I'm going through the origin, which I need to with direct variation, so there's all that good stuff. Now, we can also do direct variation when it comes to word problems. So, for example, you buy several markers for 70 cents each. Write a function rule to describe the cost of buying markers. Well, Because I'm only buying markers and nothing else, this will be direct variation. So like y equals m times x or k times x. Because every time I buy a marker, I'm going to spend 70 more cents. So we're increasing by 70 every time. And the starting value is 0, because if I don't buy anything, then I haven't spent any money. And so really my rate of change, or my constant of change, or my constant rate, is 70 cents. So my slope is 70 cents. We just replace m with 70. And so there you go. Another way to think about it is I could find the slope by doing, like, if I buy 0 markers, I spend $0. If I buy 1 marker, it costs me 70 cents. And so I can still find my slope by doing 70 minus 0 over 1 minus 0, which is 70 over 1, which is 70. So all the fun things. Now, we can also do a really basic non-real life example. So if the 0.5 comma negative 20 is on the graph of a direct variation equation or line, we can write the function for that. So it should look like y equals k times x or m times x. Doesn't matter. This is just your constant or your slope. And I can find the slope because, again, 0, 0 is always a point on direct variation. So really, to find my slope or to find that k value, I really just need to do y divided by x. So here's an x and here's a y value that I can use. We'll do negative 20 over 5, which means that my slope or my constant of variation is negative 4. So we'll just replace our slope with negative 4. And there you go. That's it. Super easy. And so lastly, the following points vary directly with each other, which means that they follow direct variation. Find the missing coordinate. So we want to find this missing value here. So because they vary directly, they have the same ratio. They have the same slope. So if I write my slope ratio as rise over run, or y over x, this is confusing because this variable is x, but x over 1 will need to be the same as 14 over 2. And so there's lots of different ways we could solve here, but I like to cross multiply. Remember, we talked about this before. 14 times 1 is 14. X times 2 is 2x. And then solve for x by dividing by 2. So x would have to be 7. So hopefully that all kind of makes sense. Kind of basic for now, but we're going to talk about it more tomorrow. So fill those out for now, and we'll do more later.